Hello and welcome back. In this video, I want to continue the discussion that we already started about the different data types in Python. Specifically, I want to talk about numbers. I want to talk about numbers in Python. If you remember in one of the previous videos, we talked about something called strings. And we said that if you want to represent textual data in your code, if you want to represent text in your code, we use the string data type. But what if we want to represent numerical data? What if we want to represent numbers? That's when the numbers data type, and we're going to talk about what the numbers data types are, that's when we start using them. It's very important to understand numbers in depth. This is not just going to be useful to you for learning Python. It's just going to be useful to you for being a solid, good programmer in general. So pay attention to this video, because in this video, we're going to talk about everything you need to learn about numbers. When we talk about numerical data in the context of programming languages, there are two main numerical data types that are very popular in almost all programming languages. One of them is called integers, and the other one is called floating point numbers, or float for short. So two different numerical data types, integers and floats. Okay, what are they? What do they mean? Let's start with integers. So when we talk about integers, we're basically talking about whole numbers, numbers that can be written without any fractional component. So for example, if you say the number 5 is an integer. It is a number that doesn't have any fractional component. The number 4, same thing. And also negative numbers as well. So the number negative 10 is also an integer. It's a negative integer, but it is an integer because it doesn't have any fractional component. In addition to that, the number 0 is an integer too. Okay, so that's what an integer means. It's any number, any whole number that doesn't have any fractional component. It can be positive, negative, or 0. It's very simple. Now, what about floating point numbers? Floating point numbers, on the other hand, are numbers that do contain fractional components. So for example, the number 3.5 is a floating point number, is a float. The number negative 2.1 is also a float. The number 12.6 is a float. So one common thing about all the numbers I just mentioned is that they have a fractional component to them. They're not whole numbers. So that's what integers and floating point numbers mean. The question now, though, is why do we have two different numerical data types? Can't we just say that we have a numbers data type? And this numbers data type can have any number whatsoever. It could be integers, could be floating point numbers. The reason why these are two different data types, even though both of them are numbers, is because internally in the hardware, they are represented differently. For example, an integer is most likely going to be represented as just the binary representation of that number. If you don't know what a binary representation is, I don't assume you know that if you're an absolute beginner to programming, but it's just basically a way to represent numbers using ones and zeros, using the binary system. It's not very important to understand that for the sake of this video, but I want you to understand that this representation is very different from the representation of floating point numbers, where you have a representation for the exponent, something called the exponent, something called a significand, and also a sign bit. So these two internally in the hardware are represented in completely different ways. And this actually have some implications. For example, integers, when you represent them in the hardware, when you represent integer numbers in the hardware, they're accurately represented. If you want to represent the number 5, it is going to be represented in the hardware as number 5, exactly 5. But if you want to represent the number 5.2, which is a floating point number in the hardware, there's no guarantee that you'll be able to exactly represent this number 5.2. What you can guarantee is you can have a number that is very close to 5.2, but it might not be exactly 5.2. And this could lead to some nasty bugs in your code if you don't understand how numbers work. And that's the whole reason why we're dedicating a whole video to just talk about numbers. And at the end of this video, I'll show you some Python code dealing with floating point numbers and giving you a result that you're probably not expecting, and you would think that you have a bug in your code, but it's not really a bug. It's all about how these floating point numbers are represented in the hardware. Now let's jump to the Python interpreter and mess around with these numbers. So if you remember the type built-in function, we talked about it before, but basically it is a built-in function in Python that tells you the type of a given data, some given data or a variable. You give it as an argument to type, and it tells you what the type of that data is. So for example, if I say type of hello as a string, it tells you that this type is, or this data is of type string, okay? Now let's do the same thing over some numerical data. So if we want to see the type of the number 3, for example, like we already explained, the number 3 is an integer. So we expect the type function to say that 3 is of type integer, and that's what we get. We get it's of a class int, which is a short for integer. What if we do type of -3? So we get that it's a class of integer as well, and same thing with 0. So like we said, any whole number that is positive, negative, or 0 is going to be of type int, because there's no fractional components in them. But what if we say type of 3.2? This number has a fractional component in it, and that's why we get that it is of class float, and it could be negative as well. So if we say type of -5.42, we get that it is also a floating point number. But there is another thing. There are actually two things I want to talk about here. What if we say, what is the type of 3.0? What do you guys think the type of 3.0 is? Although 3.0 is equal to 3, but if you type 3.0, the way it is going to be internally represented in the hardware, it is going to be represented as a floating point number. And that's why we get that it is a float. Same thing if we say type of -1.0. It is also a float, or type of even 0.0. That is going to be a float as well. So this is actually very important to point out, that even though 3 is equal to 3.0, but the way they will be represented internally in the hardware are going to be completely different. 3 is going to be represented as the integer 3, whereas 3.0 is going to be represented as the floating point number 3.0. And like I said before, this has implication. It's not a superficial difference. It actually has implications, like we will see later. Another thing I wanted to point out here is another way to write floating point numbers is by using the exponent. So if you say, for example, 3e minus 1, this is exactly the same as if you typed 3 multiplied by 10 to the power of -1, which is 0.3. Okay, and it is, as you can see here, it is a floating point number as well. Same thing, if you do 3e1, that is going to be the number 30, but it's 30.0 because you have an exponent. So every time you write an exponent in your number, the result is going to be a floating point number. So the type of 3e1 is a floating point number. So why do we care that much about that? Why do we care about the type of the numbers that we're dealing with? Well, like I said before, the type of the numerical data has implications in your code. And one of these implications is when you use arithmetic operations. And that's what we're going to talk about next. We're going to talk about arithmetic operations that you can perform on numerical data. Let's start with addition. So addition is pretty simple. Let's say you want to add two integers. So let's say 3 plus 2. You get the number 5. But what's more important here is I want you to pay attention to the type of the result. So in this case, we're adding two integer numbers. We're adding 3, which is an integer number. We're adding this to 2, which is also an integer number. And the result is 5, which is an integer number. So if you want to do type of 3 plus 2, that will result in an integer. Subtraction is the same thing. If you want to subtract, you can say 3 minus 2, and that results in a 1. Again, the result is an integer. Multiplication is the same. You can multiply 3, multiply that by 2, you get the number 6. And once again, the result is an integer. So if you're doing addition using the plus operator, subtraction using the minus operator, or multiplication using the star, this is how you do multiplication. If you're adding or subtracting or multiplying integers, the result is always going to be, the type of the result is always going to be an integer as well. How about floats? Let's do 1.1 plus 1.2. You get 2.3, which is a floating point number, and that's expected. When you add two floats, the result is going to be a float. What if we subtract 3.0 minus 1.0? So 3.0, remember, 3.0 is a float. It's a floating point number. 1.0 is also a float. So we're subtracting a floating point number from another floating point number. The result is going to be a floating point number, 2.0. And same thing with multiplication. If you multiply 1.0 multiplied by 5.4, you get 5.4, which is a floating point number. Okay, so to summarize what we've covered so far, if you're adding, subtracting, or multiplying two integers, two or more integers, the result is going to be an integer. If you're adding, subtracting, or multiplying two or more floats, the type of the result is also going to be a float. We haven't talked about division. Division is a special case. I'll talk about it soon. But before we go to division, a very natural question to ask here is, well, what if I'm adding an integer to a floating point number? What is the type of the result going to be? Well, I want you to think about it and kind of like guess what the type of the result will be. You're adding an integer to a floating point number, then it makes sense that the type of the result is going to be a floating point number as well. So for instance, if we add 1 to 2.3, the result is 3.3, which is a floating point number. Same thing with subtraction. Let's subtract 3.1 and then minus 10. The result is going to be negative 6.9, which is a floating point number. How about multiplication? How about if we multiply 3.1, let's multiply that by 10, and you get 31.0. So if any of the operands are the things that are around the operator, if any of the operands is a floating point number, what Python is going to do is it's going to treat the integer as if it was a floating point number, and then it is going to do a floating point number operation. So when we do, for example, 3.1 multiplied by 10, Python is going to treat this 10 as a floating point number, not as an integer, and then it will perform a multiplication operation between 10.0 and 3.1. And that's why the result is 31.0. So I hope you're starting to develop a sense why the types of the numbers that we're dealing with, why it matters, especially when you're doing arithmetic operations on numbers that have different data types. Now let's talk about division. Division is its own beast. Division is different. Let's talk about division and see how division works. In Python 3, there are two different types of division. One of them is called integer division, which is represented by 2 forward slashes, and the other one is called division or float division, which is represented by 1 forward slash. Let's talk about division first, the float division first, and then we're going to talk about integer division later. So if we go back to the shell, to perform float division, let's say we want to divide 3 divided by 2, for example. So let's have 3 as an integer and divide that by 2. As you can see, I have 1 /, which represents a float division. You divide 3 by 2, you expect the answer to be 1.5, and it's exactly 1.5 as you can see in the screen. What's important though, what's very important here is not the actual result, but again, the type of the result. The division operation that we had, 3 was an integer and 2 was also an integer, yet the result is a floating point number. And that is always going to be the type of the result when you perform float division, when you perform division using 1 /. The result is going to be a floating point number, even if the operands are integers. Okay, and if the operands are not integers, it doesn't matter. It's still going to be, the result is still going to be a floating point number. So if you say 3.0 divided by 2, you get the same answer, or 3.0 divided by 2.0, you still get the same answer. The type of the result is always a floating point number. So yeah, let me repeat that once again. It doesn't really matter what the data type of the operand is. If you perform float division, the type of the result is going to be a floating point number regardless. Okay? How about the integer division? Let's actually perform the same division that we had before. So let's do 3 divided by 2. And you get that the result is 1. So there are 2 things that I want you to notice here. First thing is the type of the result is integer. It's not a floating point number, it's an integer. But the result itself is not the result that you probably expected by dividing 3 by 2. Let's talk about the result first, the one that we get. Basically, what integer division does is it divides 3 by 2, but the result is going to be the floor operation of the result. The fractional part will be ignored. So for example, in this case, we're dividing 3 by 2. The result is 1.5. So because this is an integer division, Python will ignore the 0.5 part, will ignore the fractional part, and only keep the 1, okay? If you do 5 integer division 2, the result is going to be 2, because 5 divided by 2 is 2.5, so the non-fractional part is the 2, and then the fractional part is completely ignored. So that's the result. It's called the floor operation. So you're basically doing the division, and then you're getting the integer part of the result. The next thing I want to talk about is the actual type of the result. So when we did 3 integer division by 2, it resulted in 1. 5 integer division by 2, it resulted in 2. So obviously the result was integer, of type integer in both cases. But what if we do 3.0 integer division 2? Here the result is 1.0, which means that the result is of type float. The result is a floating point number, which is quite interesting and can be confusing sometimes because, you know, like the name integer division gives the impression that the result, the type of the result is always going to be an integer, but it's not really very accurate. A more accurate naming for integer division is floor division. Floor is a mathematical operation which basically just ignores the fractional part of a number. So 3.2, if you apply the floor operation on it, it will be 3. Just ignore the fractional part. And this represents what integer division is doing more accurately. You're performing the division and then you're applying a floor operation. As you can see, the type of the result is not always going to be an integer. It can also be a floating point number. Again, if any of the operands of the integer division or the floor division is a floating point number, the type of the result is also going to be a floating point number. So there is a distinction now between the float division and the integer division. The float division, you basically just divide the numbers and the result is always going to be a floating point number. The result is always going to be a float. For integer division, the result is going to be the result of the division ignoring the fractional part, and the type of the result could be an integer, could be a floating point number, depending on the types of the operands. If all of your operands are integers, the type of the result is an integer. If any of your operands is a floating point number, Python is going to promote the integers to floating point numbers, and the type of the result is eventually going to be a floating point number. In some cases, though, that could be a little bit restrictive. For example, assume you have this. Let's say x is equal to 5.0. So x is a floating point number. And you want to add 2 to x. So if you want to do x plus 2, we get that the result is 7.0. That's to be expected. X is a floating point number. 2 is an integer. So the type of the result is expected to be a floating point number because, like we said, Python is going to automatically convert 2 into the floating point number 2.0. And then it's going to do a floating point addition rather than integer addition. But what if you wanted the result to be an integer instead of a floating point number? Well, let's think about how we can do this. Basically, we are adding x to the integer 2. And the reason why the result is a floating point number is because x is a float. How about if we can convert x into an integer instead? Python is not going to do that automatically, but you can do it explicitly. So to convert a float to an integer, all you have to do is surround your float with int. So you say int x. Int is a built-in function in Python. It will convert x into an integer, and then you add this to 2. In this case, both the operands are actually integers. So the result is going to be 7. Another way to do it is to surround the whole operation with the built-in function. So you can do int, and then inside you just say x plus 2. And that will also result in the number 7, the result being of integer type. Similarly, if you want to convert an integer to a floating point number, you can use the float built-in function. So if you do float, if you say float and then put, let's say, 3 inside the parentheses, you get 3.0. So the integer 3 is converted into the floating point number 3.0. And even if you want to convert between integers and strings or floats and strings, you can use the str function to do that. So for example, let's say we have the integer 5. Then if you do str5, that will return the string 5. That will return 5 as a text, as a string, not as a number. If you want to double check, you can do type of str5. And you get that it is of type string. Also, the same thing can be done with floating point numbers. So you can say str 1.234 and you get 1.234 represented as text as a string. Also, if you want to go the other way, if you want to go from a string to a number, this is also possible. So let's say s is equal to 5.123, for example. Then if you say a float of s, that will return 5.123 as a floating point number. You can double check by saying type of float of s, and you get that it is a floating point number. Also, if you have, let's say s2 is equal to 2, and then you say int of s2, that will result in the integer 2. So to summarize, Python is very dynamic. It allows you to convert between different data types pretty much very easily. So if you have a string, you want to convert it to a float or to an integer. If you have an integer, you want to convert it to a float. If you have a float, you want to convert it to an integer. Everything is possible using these 3 different built-in functions that we talked about. But I want you to remember that if you try to convert a floating point number to an integer, you will lose the fractional part. For example, if x, instead of x being 5.0, if x was 5.2, and then you do int of x, the result is going to be 5. So the integer conversion will completely ignore the fractional part of the floating point number x. So this is also something to keep in mind when you're doing these type conversions on your own. So one last thing before I conclude this video. If you remember, I said when you are working with floating point numbers, internally in the hardware, they are represented approximately. They're not exactly the same as the number you're trying to represent. That might lead to some unexpected behavior. But if you know how floating point numbers work and how they're represented in the hardware, it should be expected. So for example, just to show you like one of the things that are not to be expected, or it's gonna come to you as a surprise, but it actually makes a lot of sense, is if you do something like this. Let's say 1.2 minus 1.0. So the result of something like this, we know that the result is a floating point number, right? But the value of the result, it should be 0.2 because we're subtracting 1 from 1.2. It should be 0.2. However, if we see what the result that we get, it's going to be 0.19999, which is very close to 0.2, but it's not exactly 0.2. And if you don't understand that when you're working with floating point numbers, you're basically working with approximations, not working with the actual exact numbers, this can lead to a lot of errors in your code if you don't know what you're doing. And that's why it's really important to understand this now, not later, because bugs will happen and you will be scratching your head, not understanding what's happening. You might look at this and think that there's something wrong with Python. Why is the result not 0.2? And the reason for that is floating point numbers, unlike integers, are not represented exactly as they are in the hardware. What's represented in the hardware is an approximation to these numbers, not the numbers themselves. So keep that in mind next time you see a bug that is related to floating point numbers. And yeah, with that, I think you have a good foundation now of numerical data types, working with numerical data types in Python and beyond Python as well. Integers and floating point numbers are not exclusive to Python. You'll see these data types in pretty much every other programming language you work with. So all of the knowledge that you're building right now is going to be beneficial to you if you want to learn any other programming language as well. So yeah, I hope you found that useful, and I'll see you in the next video.